Okay, perfect. So we are going to try to create a program where the user, or we in our case now, can deposit Sol or any token and into the program. Then the program has some logic. For now, I'm thinking of something like um, you deposit it, the program then says, okay, it's locked up, or you can't withdraw for the next X seconds. We use, I don't know, 60 seconds then. And then after 60 seconds or 1 minute, you can withdraw again. So your tokens are, in that sense, locked up for a specific period in the program. And that's what we are trying to build now. And I have to say, I just woke up a few minutes ago. So I'm still a bit tired, but we will see how it goes. For now, I will definitely need some music. And then we can please play. What the fuck? Do Why does it do that? Can it please just play? What the fuck? What the fuck? Um, okay. Let's try that again in a few minutes. But let's see anchor init anchor CLI docs, because I want to see if we can, in this project, just create a new program. So with the structure, I mean, I could just copy one, but I want to see if we run the initialize command. I think it will initialize a whole new Anchor project. I want to see if there's a way to just initialize or create a new program. Um, Initializes, yeah, initialize a new workspace. And new creates a new program. That's exactly what we want. So let's go with Anchor. New, and I guess it needs a new name. We need to go in Solana Dev Programs. Here, Anchor new, and the name. Um, let's call it Anchor new treasury. Created new program. Here it is. So perfect. We know. Let's see. Anchor deposit tokens into program. I guess this is more what we are looking for the second one, but let's check this out first. This is just basic playground. Uh, so let's already import the SPL token, which we definitely need. and created transfer lamperts function. But this is like we already did. I think it's in here. Uh, I guess this is the advanced version with converting it via the price feed, but this is here. This is exactly how you do it. Basically, we would just need this and then invoke it, of course. But a system instruction for a transfer, the amount in lamperts. So I guess since it's a system instruction transfer, you can only transfer sol with that. But that's fine for now. So from account to account, and the amount in lamperts, of course. So that's pretty easy. Um, but I wanna lock it up in the program as I described. So we would have the to account. I mean, we could just set the to account to the program, but I'm not sure how. Um, and I guess it, of course, would be sent to the program, and the balance of the program then goes up. But then there's no logic that you can withdraw it, and you can only withdraw the amount you deposited. Otherwise, you could just withdraw all the balance, the whole balance, with the deposits from every user. So there is some logic we need to build around that. Let's see. Yeah, okay. Here it's the same. They basically just invoke the function and then pass in the instruction, which is the system instruction transfer, yeah, and then the needed accounts from to and the context, of course, or the amount, and then I guess this is sinus or yeah. So this is a basic send function. So this seems interesting. So the Solana Lampert transfer was transferring only Solana, and under the transfer Lamperts, yeah. So this can only transfer Lamperts, only Sol. And I guess transfer SPL are now any Solana tokens, if you wanna, or SPL tokens. Let's create our function design module under the transfer announcements at the following. And the authority, I guess, is the authority which, um, yeah, has the authority over the tokens or the mint program or something like that. CPI program is the token program, yep. And then we just call the token program, and from the token program the transfer function, I guess. Mhm. Okay, I definitely need music. This is boring, but I am confused why it stops all the time. please keep running. I just changed the win. Oh, why? Like, I'm really confused why it stops. I guess I have my headphones or headset they have touch pads on the side. Maybe there's some fatty thing or something, which keeps triggering it. Can I start it? No, this is Siri.
Ich bin mir nicht sicher, ob ich das richtig verstanden habe.
Oh, okay. Yeah, we don't need you. So it doesn't seem like click to toggle timer settings. I mean, the second guess would be there's something on my trackpad, but if we now start and switch tabs, it just stops. This just really annoys me. Let's then go here, look for some coding. Uh, I hope it's copyright free, and it's probably not. And this stops as well. So it's caused by the operating system, I guess. Or maybe OBS. I guess it could be OBS then. But this is the first time it's doing that. Um, okay. But that's nothing I want to spend too much time now on. Using PDAs and SPL token in Anchor. Let's go over that. Introduction. Trust program invocations. Yep, we already did that. We know how that works. PDAs. Program derived accounts. I have to say, in the first videos or live streams, I think I thought PDAs are program data accounts, which kinda would make sense, but PDA means program derived accounts. Token program with a new anchor program. Yeah. This article, prior knowledge to Solana Anchor, we have that. Building a safe token transfer app. How do we build this? How much RS to get the... This app is just a program of selling funds that get stuck forever. The sender of funds has an opportunity to safely withdraw the tokens. Knows that they will be paid by Alice. Alice needs to pay Bob 10k. And Alice initiates a safe payment with Bob because she wants to have a peace of mind and avoid any fat finger scenario. Alice funds the safe payment and creates a new SafePay ID that can be used to reference their specific payment intent. Alice sends Bob a URL that references the new SafePay ID. Bob can use that SafePay ID to redeem his tokens. So I guess this is more or less exactly what we want to build. We deposit tokens into a program, and this is done with a unique identifier. And then if you open our UI with that identifier, which authorizes you that you are allowed to withdraw, then probably we hash it or something and provide it to a smart contract or program to prove that you are authorized to withdraw. If Alice fat-fingered Bob's address, or if Bob cannot find his keys anymore, Alice can safely pull back her safe payment before the transfer is complete and initiate a new safe payment towards Bob. Yeah, of course. Initializing deposit. Instruction invoked by Alice creates a new safe payment intent and defines the parameters for it. Initialize the escrow. So escrow is basically like the treasury, if you wallet owned by the safe program. Moves the fund from Alice wallet to the escrow wallet. So again, here I think you move the funds not to the program, so instead you move it to a PDA or a how's it called, ATA or something. assign token account ATA. But anyways, but uh, exactly for the reason that not all funds are in the program, I guess, and you can see how much funds are in your ATA, so you can verify easily how much has been deposited. Complete instruction invoked by Bob. Move funds from your escrow wallet to Bob's wallet. Yeah, withdrawing. I guess this will be easy. The hard thing will be creating the safe. Pullback instruction. Okay, so this basically means Alice can withdraw as well as long as Bob hasn't withdrawn. Actually, let's just follow this tutorial. This seems quite nice. Let's copy this account. I I get everything, but um, the first one, the IAX, confuses me. A primary key that allows us to derive other important accounts. I guess based on that key, we derive the token or escrow wallet account. Let's see. Let's just go with the tutorial. Sorry, DAC. I think gave me a cold or something. Yeah, we don't need Alice. Let's remove Alice. Let's remove Bob. We keep these comments because they are just self-explanatory. The amount of time was sent. This is self-explanatory as well. Let's keep that for now. So, initialize and deposit instruction. What does it do? Initializes the state account and initializes the escrow wallet account and moves the funds from Alice wallet to the escrow wallet. Sorry. Yep, this is what I'm actually interested in, how this is done. Why is it needed? Yeah, we know that. Parameters. Amount of tokens, of course, the amount Alice wants to give to Bob, and the application ID, a unique identifier. Uh, yeah, okay. This is like the identifier then, which is then provided in the URL you give to Bob. I guess at least at this point. But this makes sense. So this is just a public struct where we have tons of bytes in this seed. Like this is really unique then. Yeah, this is definitely unique. We have the user's key, sending and receiving key, and we have the. Okay, I guess I just wanted to say I would just use the user and receiving key. This is unique enough to me. But I guess if you have multiple transactions from the same person to the same person, um, with the same currency or token, then you definitely need the uh, transaction identifier here. So this makes sense. And um, yeah, I do not fully get everything. Uh, RAN, token program, system program, they are clear. wallet to withdraw from. Okay, this is the wallet, I guess, where the funds get deposited, the token account, yeah. Okay, and the wallet to withdraw from is created like that the sending user is the one who is allowed to withdraw, and the mint uh, of that wallet is the mint of the token that's being sent. So this is like, okay, this makes sense and kind of self-explanatory if you go over it. But it's the first time I'm seeing that. So user sending is the signer, user receiving as account info, of course, is Bob, can be anyone. Um, yep. Okay, yeah, makes sense. I think I understand everything. So, oops, let's copy that and paste it. So, this is just what we have copied before. So I guess I haven't hit copy. Oopsie. Let's go up again. Copy and it's so boring without music. And paste. Derived PDAs. Yep. Okay, like this is quite complex in a sense. I mean, they all are basic steps, and I get everything what they are doing. I mean, we have done it before in like other programs we did in the last videos, but this now combines a lot of the things together. So this is how it gets complex. Users, this can. This, I don't want Alice and Bob. Alice is used. DVC wallet that has already approved. The escrow wallet. Um, okay. Okay. I think what I wanted to do is just follow the tutorial for now, then see if it works, create some tests, play around with the tests, and then make slight modifications to dig deeper into how things actually work. Initialize a new grant. We take as context the initialize new grant, which was, or is this? The application identifier, yeah, which is just a random identifier. State bump, wallet bump, and the amount. Okay, so first time I'm seeing vec, I guess it means vector. Um, so let's go over the comments. We now need to call into the token program, transfer our funds to the escrow wallet. Our state account is a PDA, which means that no private key exists for the corresponding public key. Our state account is a PDA, which means that no private key exists for the corresponding public key, and therefore this key was not signed in the original transaction. Our program is the only entity that can programmatically sign for the PDA, and we can do this by specifying the PDA derivation hash key and using CPI context with new signer. So this is interesting because I'm not quite sure what the state account is, or do, or does, but uh, the rest is clear. Like if you have a PDA, only the program has authority over the PDA to do or sign things in that sense for the PDA. So I guess you could say the program is the it is now it sounds really dumb. The program is the private key of the PDA. Like yeah, I guess you get what I mean. This specific step is very different compared to Ethereum. Okay, that's interesting. I have very few knowledge about Ethereum. In Ethereum, accounts need to first set allowances towards a specific contract before the contract is able to withdraw funds. In this other case, the safe fee program can use Bob's signature to authenticate the transfer instructions and to the token contract. Okay, I don't get why Bob has to authenticate since he's basically the one receiving. And I thought to receive, like, you get something, why would you be required to authenticate? In our case, I get why you have to require, because you really only want Bob to withdraw. But from reading this, okay, let's just continue. The bump vector. Okay, inner, this is basically again just creating the bytes for the seed, I guess, because this is exactly state, sending user, token, IDX, and bump. Um, this is exactly what we use as seeds. Okay, so transfer instructions. Okay, and I guess now I get what the stage is. Think the stage is a simple PDA with enum to just easily and quite fast get the state of the actual transfer. Sorry. And okay, so let's copy this whole thing and let's just use two fingers. Then it's easier to actually scroll. Pub function initialize grant. So let's put it in here. Pub. Is it safe? Maybe it formats? No, it doesn't. But the format seems good. Mark stage is deposited. Yep. The question mark at the end will cause the function to return early in case of an error. This pattern. So I guess. So I've just started Rust development. Um, yeah, like as you can see with the videos 2 weeks ago or something. And I guess without the question mark, it would continue after an error, and now it just would just like return out of the function, out of the scope when an error is, and won't continue afterwards. Um, this is something I might need to want to read docs on later. But for now, I mean, I got the logic that's done here, so let's continue. You may notice that our constructor accepts two surprising parameters. Are passed in the instruction set in order to compute PTS for the account's application state, escrow wallet state, where You may notice that our constructor accepts two surprising parameters. Is this instructor? A constructor? What's the constructor? And there's nothing surprising for me. The constructor, you may find surprising that the constructor takes in two surprising parameters like the state, the enum. But where hmm? I don't get it about what he's talking here. Anchor recognizes that those two are PDA accounts because we specify seeds and bump for them in the instruction set. You're talking about the transfer instruction? Okay, this confuses me. PDAs are accounts that can only be signed by a program. Yep, we know that. That's why it's called program derived accounts. And think of a PDA as an account whose private key has only known to the program. Yep. In our case, this means that updating the program state and authority over the escrow token wallet is possibly only through the program that we are building, which is gated by the business logic that we coded up. Yeah, makes sense. As you can see, these PDAs have an init statement, which means Anchor will automatically create these accounts through a system program call. So I guess this is talking about here. We initialize, of course, if Alice now wants to send funds, there isn't a PDA for the transaction yet. So we initialize a new PDA here. We initialize a new PDA. We would now see if we have the struct for withdrawing that we don't initialize in the withdrawing struct. Let's confirm that what I said is right. Yep, complete grant or withdraw grant, I guess, it just mutates the existing account we don't initialize, and we initialize only the wallet to deposit to. I guess that's the ATA, was it called? I guess the token account of Bob, which Bob has the authority over, but you need a token account for every token. So if Bob shouldn't have a USDC ATA, then we would initialize if needed. I guess that's what it does. So let's recopy that, and the MacBook is getting hot. I don't know why. You may notice here we had that. Complete instruction. What does it do? Move the funds from the previously funded escrow wallet to Bob's wallet. Yep. Why is it needed? Requiring Bob to explicitly withdraw funds to their own accounts to the to his own account ensures he that ensures they have the key to access the funds. Okay. Um, public struct complete grant. So I am not sure what has one does, but so let's see where application state is the account and state. Let's see how we initialize that. application state. And here we don't have, what does state have? State has user sending and user receiving. So I guess we make sure that the state struct actually has those fields set and they are not undefined or something. I guess that's what's done here. Um, the escrow wallet is of course only mutated because we initialized it before and then we just need the seeds for it. That's clear. Init if needed, yeah, we went over that. And since we initialize a token account, we need the mint and the authority over it is the user receiving, so only the receiving user can interact with that PDA, I guess, or yeah, ATA if it's a token account. But yeah, I have to check when it's called what. Users and accounts in the system. Okay, we have the user sending, yep. We have the user receiving, which is the signer. Of course, Bob is the signer because he wants to withdraw, and by that he is the receiving user. And by making sure the receiving user is a signer, the receiving user, like you can't, if the receiving user would just be account info, we could basically pass anything as receiving user, and then signer could be something different. Mint of token being sent, yeah, so we need the USDC mint address. Okay, yeah, no, that's clear as well. Oopsie. Complete grant is a public struct, so let's paste that here. Okay, so you see now why I said in the beginning, this gets um, not complicated, but you can combine lots of things now and here, and it gets complex. If you look at the other programs we did, like 60 lines. Oh no, that's the testing. You can't use that to compare. Um, yeah, like 50 lines with simple structs, simple logic. So this is getting complex now. Or the first time I'm using something or writing something that complex. Complete, complete. Finally brings Bob in the picture. One important difference between the last two accounts is that Alice is not designer anymore. Yeah, we went over that. But now Bob is designer. Another important note is the presence of associated token program. This program defines the convention and provides the mechanism for finding the unique wallet address to USDC the user holds. So I guess, yeah, with that we can find the, so ATA I guess means associated token account from the user if he already has one, I guess. Is that it allows our program to send tokens to Bob even if they do not have a USDC token account. Hence the init if needed. Exactly how we um yeah like interpreted it. Clause during the account definition. Factoring out a small payment function. Paying out the escrow can be as simple as calling the transfer. Right, we just defined the struct until now. So we of course need to define the function. And as it seems this is not a public function, but let's continue. Paying out the escrow can be as simple as calling the transfer function from once again. But we should be doing more than this if we want to do things correctly. I guess some business logic for security and everything. Since the escrow wallet is created specifically for the safe payment instance in question, we should clear it up. Close the wallet once the payment is complete. Yep, you get the rent of the PDA then out. and there is no use for that account anymore. Okay, so yeah, we're basically removing it from the blockchain again after, yeah, like I guess that's the wrong term. The transactions, everything are still valid on the blockchain and safe there, but the PDA is not open anymore. You can't find it or interact after it has been closed with it. Once the payment is complete and there's no use for that account anymore. By closing the wallet, Alice can get back the lampots. Yeah, she put in as friend. Yeah, we said that. Um, a small utility function that allows us to transfer funds out of the escrow. A small function, yeah, sure. But let's go over it. User N, sending, receiving, mint, escrow wallet, application identifier, state, token. I am not sure what the bumps are yet and for what they are used for, but we will figure it out. Oh, a cat. Again, creating these seeds here, I guess. Where do we use inner? Ah, inner is in here. Okay. Mm, transfer from escrow to destination wallet. What's the destination wallet? Okay, that's the ATA, I guess. Yep. Da. Context with new signer. Yep. So the signer is the ATA? Nee, oh, the signer is outer as slice. Okay, that's our PDA. That's an PDA, the signer. The transfer should close. We should close if there is no uh, amount left, since Bob can basically specify the amount he wants to withdraw. So if he withdraws only the half, of course we don't want to close. And if should close, uh, closing account or close account, it's the account, the destination where the rent goes, I guess, and the authority, and then again just cross program invocation. Mm, okay. And now it makes sense why this is not public, because we only want to call it. Or was it public? No. Um, it's okay if it's not public, then I guess we need a third function to call this. And below is the instruction code. Yeah, okay. Complete grant, and then yeah, complete grant calls transfer escrow out. And yeah, if stage from yeah is not funds deposited, um, stage is not wallet. Yeah, okay, yeah, yep, makes sense. I have to be honest, and I think my knowledge until now is not that advanced that I could write this from scratch. Um, but that's why there are tutorials, right? So let's see now if they provide. Is there's more? Ah, the pullback instruction for Alice to pull out the funds. And now it makes sense why we moved transfer escrow out into another function, because I guess we call it here again. Um, let's just copy it. And yep, it's getting really complex. So the pullback, yeah, as I said, we call the transfer out here again. So please provide the tests. Source code, yep, I want to have a look at the source code. You hope, yep, you have tests. Yes, 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 yes. Let's copy this shit and go to our test. Oh, basically, we can copy everything and just create a new file and call it treasury. Treasury. Up, up, up. But does it create? Does assert mean we can add balance to a wallet for the just for the test? Read mint is not used, so I'm not sure if that target types would be treasury then. But Anchor should be installed. Coral XYZ Anchor. Project Serum Anchor. Can we just use Coral XYZ? Does that work? Let's see if it let us do that and doesn't complain. But we need, of course. Oh, oh. Done at anchor.provider. Set provider. Okay, you are complaining me too much. We are going to use um we are going to use treasury. That's fine. And install project serum. Can you stop complaining? So this still does not work. Anchor.set provider. So it's actually right. And how do we get the does not return a provider. So, da, da, provider is then new. Yep, new anchor provider, and you want the connection. Yo, where should we get the connection from? What the fuck? Connection and wallet. And I guess for wallet again, you just need connection or something. There was something like that because I don't have wallet. You're kidding, right? Connection. Endpoint. Yeah, but we want uh so you're still complaining about the wallet, and the wallet wants. Oh, yeah. Okay, okay. But why does it work for him? I mean, how old is this? 3 years? Oh shit, okay. There has been a lot of changes, I guess, since then. I didn't know that. I didn't know that. Um, okay, okay. I mean, I guess we learned a lot of from it. And okay, so I will delete this. Let's see if this thing just builds. I guess it won't even build. Yeah, okay, it doesn't build, but um, then you know what? Let's take it as an example, move it out, and um, example, yeah, of course. So, and then we initialize a new anchor, new treasury. It doesn't. It doesn't exist, bro. Why are you telling me that it does exist? Oh, I didn't know you have the logs here. That's interesting and helpful. But why do you tell me that it does exist? And I guess we can delete Oracle Master as well. Let's try that again. Anchor new treasury. Oopsie. Program already exists. Yeah, bro. It doesn't. But you probably have some leftovers. Was that your issue? Was that why you were complaining? Yep. Okay. So, I think I will do another stream later today, um, creating our treasury, because now it's already an hour and I don't want people to like view an whole hour of video, just to get to the point where we actually start coding. Um, okay, okay, but we learned a lot and that's important. So let's end the stream here, and I will probably stream later today again.